Welcome to the another video where we are going to solve problem using superposition theorem. As question has asked, use the superposition theorem to determine current in the branch AB. So now in this problem we have to identify the current in the branch AB or current flowing through 6 ohm resistor. This is the circuit given. I hope all the parameters are visible. The reason of selecting this question to solve was the circuit seems bit complex than the previous, but it has only voltage source. So let's see, both the voltage source are in volt and all resistors are in ohms. Okay, now let's start using superposition theorem. If you get such types of complex circuit, so you can modify these circuits into simplified circuit, because it's visible that this 24 ohm and this 24 ohm are in parallel with each other. Okay, and this 24 is also parallel with each other. That's why we can convert the given circuit into the simple circuit. You must remember that you cannot change these resistor, but rest of the circuit you can change. You can make few changes or you can simplify the circuit as per requirement if it is possible. Okay, so the circuit will be, so in the given circuit you can do one thing is this 24 will merge into a single resistor and you can replace that resistor by, okay, so this is how your circuit will be. It is already of 6 ohm and this one is of 6 volt. This circuit, since these two are in parallel with each other, you can do that. R equivalent is equals to 24 into 24 upon 24 plus 24, which will give you 12 ohm. You can try. Then this one is point A and this one is point B. It will remain 6 ohm. And this one is also similar to previous one. A 24 are also in parallel, so you will get a resultant resistance or equivalent resistor of 24 into 24 upon 24 plus 24, which is equals to 12 ohm. And the resistor over here is 2 ohm, then 6 ohm and 12 volt. This is the circuit. Okay, once you draw the circuit, now you will use the same process as previous. Okay, so be clear. Once the circuit is completed, let's start the KVL. Now you will implement your superposition theorem on this. Okay, so you can, how many sources are there? There are two sources. One is of 6 volt and another one is of 12 volt. Okay, so let's write for, you can consider any of the sources. I am considering the source, considering 6 volt source only. Okay, after considering 6 volt, you have to draw the circuit. So don't forget to draw the circuit in the problem. So it is of 12. This one was 6 ohm, it's of 6 volt. This one was 12. The now main circuit is this. Okay, so this one will be your main circuit, 12 ohm. Since there are two sources, 6 volt and 12 volt, you are considering 6 volt only, so you have to short circuit the 12 volt. That's why drawing this 12 ohm, you will draw 6 ohm and then short circuit, because there is this 12 volt will be short circuited. Once this is done, you have to identify total current flowing from A to B in the given circuit. So you can use any of the method, but now we will use current divider rule, and for the current divider rule you will have to identify R equivalent. In order to identify R equivalent in the given circuit, let's start from the farthest end. As I told you previously, R equivalent is equals to, we can initiate from this point. Okay, 12 is parallel with 6, so 12 is parallel with 6, or 6 is in parallel with 12. Once these two are in parallel, rest of them appear in series, so plus 6 plus 2. Okay, and the whole combination will be in parallel with 12. Okay, once you will reach at this point, you will find that that resultant resistance will be in series with this, so you will have to plus 6. I hope you know this process. I have done nothing, just substitute. Now substitute the value. Let's put this is 6 into 12 upon, you can perform it by reducing the circuit also, plus 8 and is parallel with 12 and plus 6. Okay, once you will conduct all of them, you will find that the resultant resistor will of 12 ohm. So once you get the total resistance, you will have to identify the total current flowing through this. The total current flowing through circuit will appear as I is equals to V by R EQ. Okay, V is 6 upon R EQ is 12, means 1 by 2, which is 0.5 ampere. After acquiring the current, you can imagine the reduced circuit. Okay, so I will draw the reduced circuit. Let me draw the circuit so that you will get more clear picture. If 12 and 6 are in parallel, what will you get? Therefore it becomes 12, and this 12 is of opposite branch, which is this one. Okay, that's how we apply the current divider rule. Once this is done, let's implement superposition considering 12 volt only. Okay, now using 12 volt source only, what will you get after using 12? So 12 volt only, you have to draw the figure. Okay, now let's draw the figure. It's 6 ohm and then 12. Okay, the 6 volt will be short circuited, and then next one is 6 ohm, 12 ohm, next one is also 12 ohm, and the circuit below is of 2 ohm, and this one is of, that's how our circuit look like. Okay, this is point A, this is point B. You have to note, for the note also you have to keep this 12, and here is 6 ohm, and this one is of 12 volt. Okay, once this is done, again we can use current divider rule as previous. Okay, so let's use current divider, because our task is to identify current of this current through 6 ohm. We can notice that if you will look R equivalent, now you have to notice from this point, from this point the farthest end is this, and these are in parallel. That's why 6 is parallel with 12. Okay, and then is parallel with, in series with 6 plus 2. Okay, once it is done, then you can notice that these are in parallel with 12 and are in series with 6 ohm. If you will solve them, you will get 4 plus 8 plus 8 is parallel with 12 plus 6. Okay, means 12 parallel, 6 plus 6 is equals to, again the 12 ohm will be answer. Once you acquire the R equivalent in the given circuit, you can replace these two voltage by these two resistors by a single resistor, as they seems in a parallel. So now you will replace 6 and 12 in parallel with each other, will give 4 ohm. Okay, that's why your now calculate I total for this case will be V by R equivalent, which is equals to 12 by 12 is equals to 1 ampere. Okay, once you get the current, this 1 ampere will flow through this direction. Okay, flow through this direction, this point to this point. So till this you will get 1 ampere. 1 ampere will divide into two branches as 12 is parallel with this branch. So using current divider rule you will get I from A to B, but we can now see that the current is flowing from B to A in this position. So I B to A is equals to total current. This time total current is of 1 ampere. Total current into opposite branch. Okay, for this branch opposite is 12. 12 upon 12 plus 12 means 0.5 ampere from B to A. Okay, so now you write that I total is, after solving the problems we find that current flows from A to B in from 6 volt and current flow from B to A while using the 12 volt. Therefore the resultant current will be are in opposite direction. Therefore IBA minus IAB. That's why total current is 0.5 minus 0.25 as their direction, as they are flowing in opposite direction. That's why I is equals to 0.25 ampere. That's what is our answer. So that's how you can solve the problems. Don't get confused while seeing the complicated circuit. You can simplify them in a very simpler manner. So once more, let's summarize what we have done. Initially we are provided with this circuit and we find that 24 and 24 ohm are noticeable, are in parallel, and we have nothing to find between them. That's why we convert those circuit into a single circuit, or we find an equivalent circuit out of them. After finding the equivalent circuit, we converted the circuit into this form. Once you convert the circuit into this, you find current first using 6 volt source and then find the current using 12 volt source only. While considering a one voltage source, other voltage source was short circuited. Once all the process was done, we found that current was flowing from A to B while using 6 volt, but current was flowing from B to A while using 12 volt. So we've noticed that the current are flowing in opposite direction, so that instead of adding, this time we have to subtract from higher magnitude to lower magnitude, and the resultant current is 0.25 ampere. That's how you can solve these problems. Thank you.